Now let's start with a new topic, revisiting irrational number. As we all know, irrational numbers are those numbers which cannot be converted into P upon Q form, where P and Q are integers and Q must not be equal to 0. Example of irrational numbers, root 2, root 3, pi, these are the examples of irrational numbers. If any number P divides the square of another number Q, then in that case, the P divides Q as well. Now example, if 2 divides 2 square, it means that 2 should divide 2 as well. This is the fact, we know this. And next, this fact is applicable only for rational numbers, not for irrational numbers. If any number found not following this fact, then that number is irrational. And we are going to use this fact to prove irrational number as irrational. We are going to prove this irrational number in 2 steps. The first step is assumption. The first step is assumption and the second step is contradiction. First step is assumption. We have to assume that root 2 is not irrational, but it is rational. If root 2 is rational, then we must be able to convert root 2 in P upon Q form, where P and Q are integers and Q is not equal to 0. Also, assume that P and Q are coprime. This is our assumption. This is very important assumption. We have assumed P and Q are coprime. What is coprime? Coprime numbers are those numbers which do not have common factors other than 1. Now, this is our assumption, and in the next step, we are going to square the equation. We are going to square the equation. Squaring both sides of the equation, we got root 2 square is equal to P square upon Q square. Next, it will become 2 is equal to P square upon Q square. Okay, if we shift Q square to the left side and 2 to the right side, we'll get Q square is equal to P square upon 2. It means that this 2 is dividing P square. If 2 is dividing P square, that means 2 is dividing P. And if P is being divided by 2, that means we'll get P is equal to 2C. 2C, some other integer. Why? Because after dividing P, we are getting some other integer and we have considered C as that integer. So P is equal to 2C. Okay, where C is an integer. Now put this value. Put this value in equation 2. When you put this value in that equation, we'll get Q square is equal to 4C square upon 2. After solving this, we'll get 2C square. And now, when we shift 2 to the left side, it will give us Q square upon 2 is equal to C square. It means that this Q square is getting divided by 2. And if Q square is getting divided by 2, it means Q is also getting divided by 2. It means that P and Q, both the integers, are getting divided by 2. But this is a contradiction. Why? Because we have assumed that P and Q are coprime. But now we have found that P and Q are getting divided by 2 other than 1. So P and Q are not coprime. This contradiction has arisen just because we have assumed incorrect. What we have assumed? We have assumed that root 2 is rational. And this assumption went wrong and we got to know that root 2 is irrational. It is proved. Let's take another example to prove that 5 minus root 3 is irrational. Okay, we can prove this by assuming that 5 minus root 3 is rational. This is our assumption, step 1. And if it is a rational number, 5 minus root 3 is a rational number, means we can convert 5 minus root 3 in P upon Q form, where P and Q are integers. Now rearrange the terms in equation 1. We get 5 minus P upon Q is equal to root 3. Now it is equation 2. It is clear that from this equation, integer, 5 is integer, P is integer, Q is integer. Means integer minus rational becomes rational, the left side becomes rational, and right side is irrational. Means both sides are not equal. If both sides are not equal, it is a contradiction of equation, and this contradiction has arisen just because we have considered 5 minus root 3 as a rational number. It is the contradiction to the assumption. That's why we can say that 5 minus root 3 is the rational number.